12 x to the power of 12 divided by 3 x to the power of 3. Well, at first glance, we obviously just divide the numbers first, right? Before getting to the letters and stuff, we just divide the numbers first. So 12 divided by 3, that is 4. Now, remember this law, a to the power of m divided by a to the power of n is equals to a to the power of m minus n. So we apply this law here. So we have the base x, and like here is also base x. So yeah, they have the same basis, which means you can apply this. So for this one, the index is 12. So the m in this case is 12, and the n in this case is 3. So let's just apply it right now. 4x to the power of 12 minus 3, right? Because it's m minus n. 12 minus 3, that is 9. So we're just left with 4x to the power of 9. And that's it. Now don't like make a careless mistake and write 4x to the power of 4. Don't think that you divide 12 by 3. No, you don't do that. You only divide 12 by 3 when it's the number beside the x. But when it's a power, when it's an index, you minus it. You don't divide it, so this is wrong. 256 y to the power of 256 all to the power of 1 over 8. Well, first of all, let's just convert this into index form first. So 256 is divisible by what prime number? Like, what is the lowest prime number that it can be divided with? 2, right? So yeah, we divide by 2, and you get 128. 128 can be divided by 2 again, and you'll get 64. And that can also be divided by 2, and you get 32, and you divide by 2, and you get 16, and you divide by 2, and you get 8, and then 2, and you get 4, and you divide by 2 again, you get 2, and then finally you divide by 2, and you finally end up with 1. Right, so you just keep doing this until you end up with 1. So how many 2's are there? 1, 2, 3, 4, 5, 6, 7, 7, 8. There's 8 2's. So we can, from this information, we can get that 256 is equals to 2 to the power of 8. Because this is 2, and there are 8 2's. So yeah, that's where you get 2 to the power of 8. So I'm gonna put this here. I'm gonna rewrite that as 2 to the power of 8 y to the power of 256 all to the power of 1 over 8. Okay, now we're gonna bring back another law, a to the power of m all raised to the power of n is equals to a to the power of m times n. Now we apply this law here. So what's happening here is just the power, this index, is going to distribute to both of these right here. And since it's a bracket, and raised to the power, it's technically in the same shape, in the same format as this law right here. So we can apply it. 2 to the power of 8 times 1 over 8. And then y to the power of 256 times 1 over 8. 8 times 1 over 8, that's just 1. But I won't write it because, well, yeah. And y to the power of 256 times 1 over 8. 256 times 1 over 8 is equals to 256 over 8. 256 divided by 8, right? And when you do the calculation, you will end up with 32. So we end up with y to the power of 32. And this is our final answer. Okay, moving on. X to the power of 64 over 16 to the power, y to the power of 16 all to the power of 1 over 4. Okay, so first of all, we convert this into index form again. 16, what's the lowest prime number it can be divided by? Can be divided with 2. 16 divided by 2, you get 8. You can divide that by 2 again. You can divide this by 2, and you can divide this by 2. How many 2's are there? 1, 2, 3, 4, So 16 is equals to 2 to the power of 4. Now let's just put that in. X to the power of 64 over 2 to the power of 4, y to the power of 16, all to the power of 1 over 4. Okay, so like always, we distribute the power to all of these numbers. X to the power of 64 times 1 over 4 all over 2 to the power of 4 times 1 over 4, y to the power of 16 times 1 over 4. Well, let's evaluate each and one of these. 64 times 1 over 4 is 64 over 4, which is equal to 16. So we're left with x to the power of 16. 4 times 1 over 4 is just 1, so I'll write it as 2. And 16 times 1 over 4 is 16 over 4, which is 4. So we end up with y to the power of 4. And that's our answer. Okay, moving on to D. I'm not gonna read this question, bro. Alright, so we're gonna bring back this law again. A to the power of m root n is equals to a to the power of m over n. We apply it here. Since we have a root 3, we have a cube root, we can distribute this root to each and one of these. And we use this law. So we can rewrite this as x, oops, what the heck is that x? X to the power of negative 6 over 3, right, m over n, over y to the power of 3 over 3. And just a reminder, I got this 3 from the cube root. Okay, now we just, this same mode, we distribute it to all of these. So x to the power of negative 2 times negative 3, y to the power of 5 times negative 3 over x to the power of 3 times negative 3, y to the power of negative 1 times negative 3. Alright, now we just evaluate every single one of these. Negative 6 over 3, that is negative 2. 3 over 3, that's 1, so I'll just write it as y. Negative 2 times negative 3, negative and negative, so that becomes positive. 2 times 3, that's 6. 5 times negative 3, that's negative 15. Over 3 times negative 3, that's negative 9. Y, negative 1 times negative 3. Negative meets negative, becomes positive. Alright, so there's actually two ways to simplify this. You can either simplify this fraction and then you combine it with this, or you can combine it all first and then you simplify it at the end. Either way, you will get the same answer. But I am going to combine these two fractions together first. So this is multiply, right? We bring back this law, a to the power of m times a to the power of n is equals to a to the power of m plus n. If you have the same base multiplied by the same base, and it has power, it has an index, you can just same base and you add the index. So in this case, there's an x and there's an x. So we can apply this law here. X to the power of negative 2 plus 6. And the y is just going to stay the same. Because, well, there's no other pair here. There's no pair. There's no y pair. And this law is only, it can only be applied when the bases are the same. And for the bottom number, there's no x pair in here. So I'm just going to write it as x to the power of negative 9. And the y has a pair. This is y to the power of 1, right? So y is 1, to the power of 1 plus 3. Now we evaluate this. X to the power of negative 2 plus 6, that's 4. And y is to the power of negative 15. All over x to the power of negative 9. 1 plus 3, that is 4. Now, we're not done yet. Okay, now we bring back the same law again. A to the power of m over a to the power of n is equals to a to the power of m minus n. And keep in mind, this only works when you have the same base. Okay, so this and this has the same base, and this has the same base. So we can apply it. X 4 to the power of 4 minus negative 9, right? The minus is from here, from the formula, and the second negative is from here. Y from negative 15 minus 4. This is where I get the 4, and again the minus comes from here. Negative meets negative, that will result in positive. So 4 plus 9, that is 13. Negative 15 minus 4, that's negative 19. Now the question asks us to put it in a positive index. So we can move this y to the power of negative 19 to the bottom as a fraction, and it will turn to x to the power of 13 over y to the power of 19. And this is our final answer.